In any business today, there comes a moment, the moment you realize you can secure the code as fast as you write it. Instead of testing everything, you can just test the right things. It's not about tools, but intelligent risk management. That's the moment you choose Synopsys. Build secure, high-quality software faster. Visit securityweekly.com/synopsys. Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today. Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. Our adventuring party has just finished a short rest, and I'm your host, Mike Shima, joined by Tyler Robinson. John is off this week on an airplane as we speak. Don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, and follow us on social media and our streaming platforms. And also, if you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. And this brings us into another week of lots of vulnerabilities, I think, but lots of little vulnerabilities. And Tyler, I don't know if maybe some of these will stand out more than others or appeal to you, but the one I want to dive into first is Exchange and its Autodiscover protocol, because this is pretty simple and clever, and also one of the laziest types of attacks you have to pull off, because as what researchers discovered, there is this Autodiscover feature within Exchange. Now, this Autodiscover feature is basically intended as a usability improvement so that users can say, this is the domain that I belong to for my email, and I'm just going to type in that domain. Here are my credentials. Please go out and configure yourself accordingly, Outlook, and it will do so. But it will also, as part of that, go reach out to some basically Autodiscover dot something within the up and down the TLD of the domain that Exchange email belongs to. And when that happens, if you are the organization that doesn't own that particular domain, that Autodiscover domain that Outlook or the client is reaching out to, you can actually then have your clients, basically they're going to leak their credentials out to this taken over domain, or not, or just registered domain. I'm sort of flubbing about what all the fun, cool parts of it. So the two cool things: you can actually register an Autodiscover domain, or if you can register an Autodiscover domain within the TLD of a target org, you can collect their credentials. Now, the second part of this, though, is that originally the authentication scheme was using something like OAuth or NTLM, but what these researchers also did was just say, hey, here is a bit of a downgrade. I don't support OAuth and TLM. Please give me just a basic authentication header. And as we know, basic authentication is plain text credentials. And and they can just sit back and collect, in this case, a few 100,000, like through over 300,000 domain credentials. And I think, Tyler, you probably can appreciate this, that valid credentials are pretty much the best backdoor, the best vulnerability you can use to get into a target organization.
Yeah, I mean, especially clear text. If you're able to use one of these back off protocols to get something and downgrade to get basic auth, where you're just getting base 64 and clear text, it doesn't get much better than that. You add that into something like an Outlook rule attack, or even one of the Exchange privesks, where you're able to privilege escalate on the Exchange box with some of the chain vulnerabilities. You take this, I mean, this was rated at I think like a 9.8 or something. This is pretty serious, but you chain that to full Exchange ownership, and then you can essentially dump the domain. Any credentials that live within Exchange become vulnerable to whatever you're going to do. So this gets pretty serious, and the fact that it was so simple. I mean, we know Autodiscover's had some issues in the past, but you start to think about O365 and how it's configured. I'm not sure how deep they went into their research, but you're required to configure Autodiscover on your O365 and make sure that those Autodiscover.xml are all set up. So if there's something that gets broken there or a misconfiguration, this could be much larger than 100,000 domains.
No, it's pretty nasty. And I was also digging back into some of the so Autodiscover at least goes back to 2015, or at least that's some documentation on Microsoft's website. But what stood out to me in that documentation is that kind of the spirit of perhaps one of the reasons why AppSec remains so hard, or we haven't been as successful as we should be, because we're basically making a lot of recommendations. And here, basically verbatim from this Autodiscover for Exchange write-up on the website says, before you send a request to a candidate, make sure it's trustworthy. Remember that you're sending the user's credentials, so it's important that you're only sharing them with a server you trust. And then it goes in to say you should verify the endpoint, verify the certificate. But what I'm getting at there is that, once again, it's sort of the little bit of that OWASP top 10 approach, in the sense of, here's a checklist that says, don't do this. But if we're just stopping at the don't do this, kind of instructions to developers, and we don't have any follow-up with some automation, with some linting, with any other type of configuration checking. And as you point out, Autodiscover actually has to be configured and set up in many scenarios. Developers are being set up to fail. We're not helping them at all.
Yeah, and the Autodiscover's been around. Like, we've been using Autodiscover in one way or another with Exchange all the way back to very, very early Exchange. I think this goes back to 2013 had it. I think this goes all the way back to 2003. It was used in a different way, but that Autodiscover feature has always been, if you're able to gain man in the middle, we used to abuse this in a couple different ways. And the fact that this is just coming out, I think we're going to see more Exchange abuse, because it's one of the few things that's still left on-prem, that's exposed to the internet, that often doesn't support the multi-factor authentication. If they're not using OAuth and they don't have this configured properly, they're still using EWS or OWA, and they don't have multi-factor configured. It is one of the few enterprise applications that is still exposed, because it's a critical application.
No, that's a great point. This, multi-factor is the drum to beat here. That multi-factor now here everywhere, especially throwing on like a FIDO key-based multi-factor. But speaking of, all the way back to 2003 and, familiar things from history, there's another article with some RCEs in both VMware and Nagios. Not necessarily very pervasive, but pretty familiar, I think, to many network and system administrators. And the things that stood out to me here was just reading through the list of what the different vulnerabilities are. They're kind of all over the place in terms of attack categories. There is, of course, and once again, drum roll, Mr. Kinsella, give us that, drum roll off wherever you are, for path traversal vulnerability. So there was a path traversal in here, file upload vulnerability, and as well as a great XML DOS via XXE. And then on the Nagios side, there were 2 CVEs related to command injection and SQL injection. So really, we're going to talk a little bit more about memory safety later on, but all of these are not memory safety issues. And I think you can, regardless of your programming language, you can have that XXE, you can have file upload, path reversal, all these types of flaws in your code. So I don't know where I'm going with this other than I'm trying to find some seed of optimism that we can get beyond such simple vulnerabilities. So maybe from an optimistic perspective, I don't know how much easier does this make your job when you see these types of vulnerabilities?
These ones are fantastic. I mean, I love and hate seeing these because this is a pretty scary one, especially the VMware. You start to think about how many companies have virtualized their domain controllers, and those domain controllers live within a segmented side of the VMware virtualized hypervisor, right? If those domain controllers are compromised, essentially everything within inside the organization that relies on the authentication of LDAP or AD to do that authentication is compromised at that point. Especially something like this, where anybody on the network that can access, which is usually everybody, the 443 port of the virtual vCenter, you're essentially giving them full access to everything in the domain. And this is a pretty straightforward vulnerability as far as how the file upload and what you can do with it. Not only that, you can even take this a step further. If they don't have access, but they have login credentials as a low privilege user on that single virtual appliance, this also can be utilized to gain PrivEsk and take an elevated stance on that same box, essentially doing the same thing. So this is very, very bad in any enterprise, rated, I think, a 9.8. You know, not that usually I look at any of those scores, like I see RCE or I see file upload, like creativity starts to go. So it's a bad day.
It definitely is a bad day. Some other people that are having a bad day is anyone with an IoT device that is using a vulnerable version of MQTT. And here now we're getting into our memory safety issues. And this one is once again, a pretty simple payload. So I guess, your brain can take a week off of having to get too creative or have to do some heavy duty thinking, Tyler, I guess, when the attack here is simply construct a payload that can get into a message length that basically overflows the signed versus unsigned comparison that goes into what is the size T. So that's an unsigned value into a mem copy. And now you've gotten a massive problem in a bunch of IoT that's using this message queuing library that's intended for a small footprint IoT devices. So I don't necessarily know that the consequences of this might steer quite so dramatically as the linked article says. But then again, we haven't thrown this over to Tyler to see how creative he might be with it and where all these sneaky IoT devices might be within, segments of a network that are unexpected or weren't quite as segmented off as well as they should have been.
Yeah, you talk about IoT, and one of the things that people fail to realize is oftentimes these IoT devices have very specific purposes and they're put into high security areas. Think of something like a camera within inside of a data center or a rack. Those are typically not often segmented off because the people that are going to access them are going to be within inside of that segment, and they're utilizing that management to get to those devices. Well, what happens is those devices get compromised, and that is a single point of entry that allows us to pivot within inside the network. We used to use printers quite frequently, multi-device or scanning printers that were hooked to the internet so that people remotely could send stuff into the office or scan to share, all kinds of weird things they would do. But those are full computers that have IP stacks within inside of them, and we would write code to have code running in memory that would allow us to pivot and make a direct SOC connection or VPN connection or tunnel traffic directly into that network. So you start to think about where these devices are located, and they're often in management networks. They're often in ICS networks. They're in high security networks. There was another vulnerability this week that had to do with cameras. And once they were exposed, they noticed that all of these cameras were looking at very, very sensitive things in sensitive areas. And so the ability for us to pivot and utilize these IoT devices to traverse networks and or segments that may not have as strict security controls or endpoint detection. Maybe there's not as much network filtering. So utilizing these devices provides us a nice stealthy way into places that might be much more difficult on a Windows host to get through.
Yeah, and I think some of the things that John and I have been talking about the last several weeks is observability and monitoring of your applications. So the idea that can you create log events? Can you just monitor events and be able to trace requests and response pairs coming through your application? Because you want to be able to say, were we vulnerable to this particular authorization problem or a broken access control, something like that. But I'm going to guess too, another appeal for you going after these IoT devices is that it's very likely the forensics has got capabilities, or the after the fact has got to be pretty minimal in terms of just what they log, what they can contain, or just trying to get visibility into what's running, what's running within one of these devices.
Yeah, the integrity of the logs on these IoT devices are much less, and quite frankly, most of the time, they simply take a reboot because we're operating with inside of memory. So once you've cleared a log and or maybe overrun the logs, which is fairly simple to do on these IoT devices, they don't have very much memory or storage, and you reboot it, the forensic capability and the footprint that you're leaving behind is going to be much less. Not to mention your ability to control, because most of these are BusyBox or Linux or some Linux kernel variant. You're able to control things at the hardware level very quickly and stop things in a way that you'd probably not be able to do on a much larger enterprise device that has tamper protections, has multiple log sources, has a lot more real-time capability as far as sending that off to a SIM, being able to correlate different events and alerts between those. You're talking about very, very simple devices, very simple logs, even if you get logs. So yeah, there's not a lot that can be done forensically once you compromise those.
So on the other end of the spectrum, though, there's Apache HTTP Server, which is ancient, has the wrong connotation to it, but a very well-regarded, software stack for running most of the internet, driving web traffic. And there are some vulnerabilities in it that were reported again this week in SSRF. And James Kettle over at Portswigger got his his black hat research this year around HTTP request smuggling. Has that been addressed within this? And in this case, I wasn't so much focusing on what the vulnerabilities were so much as how they were found. So, Tyler, you had mentioned briefly in the last segment talking about bug bounties and, external researchers. In this case, I think one or two of the acknowledgments was to cluster fuzz, which I thought was pretty cool. Now, the fuzzer was not, it found, I think, low priority or low risk vulns. So it wasn't necessarily being that really bang for the buck where it's hitting something higher like SSRF, but I did think overall it's kind of cool to see that there is some fuzzing that's actually finding consequential vulnerabilities to be fixed within these types of open source software.
Yeah, fuzzing, I mean, you go back to fuzzing. Fuzzing's always been a part of application security. However, you're spot on. The payoff of actually finding something via most of the open source fuzzers takes a lot of effort and a lot of time, some very unique tricks to make it do certain things. And that's usually at the very, very bottom of the totem pole as far as priority for AppSec teams or DevOps teams, right? Like those are things that they're typically not looking at. Now, security research, that's a great niche that a lot of these security researchers are kind of filling in with the bug bounties. They're looking at things that are very pervasive. Apache, that's well used. That's covering a good swath of the internet. Obviously, that would make sense from a security researcher standpoint to go after and target those things. And we've seen the same thing this year with sudo and the research put out by Qualys around the pseudo vulnerabilities. That's a very pervasive, very high priority piece of the Linux kernel that's been around forever. So it makes sense from a security research standpoint to kind of take the time and methodically target that. That's not usually the case for most people's software, most people's AppSec programs, and what they're looking at as far as securing the code. So I think, again, this is just a highlight of what good bug bounties and security researchers are doing for the community as a whole, where we wouldn't otherwise have the time to look into these kind of things.
Yeah, and that's a great point. That absolutely comes back to the idea of how mature is your AppSec program, as well as what's your budget. Because there's just running the fuzzers themselves across a bunch of cloud instances. It costs money right there, let alone the time and effort to review and see what's exploitable, what's the security impact, and so on. Now, and I say that because we also have an article here from Chrome, the Chrome team from Google once again, who have actually quite invested a lot into fuzzing Chrome. All of the web browsers are going through fuzzing. Mozilla started off with their JS FunFuzz as well. But this article, instead of going down the fuzzing route, is saying, we know that memory safety issues are a problem. We take your memory safety seriously to take that trope from breach notifications. And they're pointing out 70% of the severe security bugs last year that Chrome had to deal with, memory safety issues. So they're going to keep doing some fuzzing, but they also want to try and say, how can we get rid of this problem altogether, which I think is a healthy approach, a smart decision to make. And they're pointing to roughly two approaches here. One, to turn all of these raw pointers into a nice, optimistically named miracle pointer, or basically better reference pointers, or basically raw pointer semantics that can make exploitation more difficult and use after free, those types of scenarios. So that's good, but they're explaining you can't just, update a C++ template for your raw pointers and snap your fingers and everything's done. It takes a lot of work, especially for a complex project like Chrome. And the other thing they're also saying is, well, what if we actually did use a language like Rust that doesn't have memory safety issues? That brings its own challenges within it, but they also document some of that. And I put the links to some of those discussions into the show notes as well. So fuzzing, I definitely think, is going to be a great tool, especially for the researcher community and your friends, Tyler. But it's also good to see how engineering side of things are considering what to do here. So I don't know if you're looking at this and getting a little bit worried that Chrome 0 days are going to be fewer and far between in 2022, or if you might suspect it's going to take a little bit longer for things to change.
Yeah, I mean, it's very lucky if we have a Chrome 0 day, to be quite honest, and then its updates process is pretty rigorous, and then the sandboxing, evasion, and all the things that Chrome does to make that very difficult is very, very hard. So there's a lot of other better ways. I just like to trick users if I've got to go that far. But yeah, it's promising to see development teams thinking outside the box. Like, how do we address memory overflow, use after free, like all these pervasive problems? How can we just address the problem, the root cause, and move past trying to continually patch these and fight that battle? And I think it's quite interesting how they're going about different aspects of trying to figure out better ways to do this. And it's quite promising from the standpoint of so many things utilizing the browser. You start to look at all the apps within inside the browser, what the browser's used for, even Chromium as an OS. This lends itself to be a much more secure environment. You start to think about Windows 10 and Windows 11 and all the things that they're doing in conjunction with Edge and Chrome, and them starting to think about all of these pervasive problems. We're getting down to where we are into the AppSec world, where applications that we use on a daily basis are going to become the exploitation path, and that's probably going to be within the next year or two. The OS is getting much more secure. It's usually the apps that introduce the vulnerabilities. So I think we're just going to start to see that circular motion come back around, where applications were targeted for the 0 days, for the entry points, because the OS is going to be much harder. The browser is going to be much harder. So it's going to be more important for enterprises to get their applications secure and do secure coding and to mature down that road, just like a lot of these other bigger projects have done.
I like that you said that, because I wanted to tie that to another article that I put in here that was about HackerOne expanding its bug bounty projects for open source bugs. And we've seen that the Linux Foundation has been investing into actually financing, paying people to do some security reviews of like the Linux kernel, some other important open source projects. They're also paying for basically things of for people to go through and fix compiler warnings, not just suppress them, but to properly fix them, to understand what's causing them. So I'm kind of curious too, how much of this, how much of this is good, bad, or maybe to use less judgmental terms, how much of this is where you would invest money in terms of expanding bug bounty for open source versus maybe putting this type of funding into fuzzing or developer awareness or education or something else? If the CISO or someone comes to you with a suitcase full of money, in addition to heading for the beach, perhaps, what would you do with it from a security perspective?
I think it's always important to kind of find that balance. This is one of those places that this adds some necessary balance to the open source world. There are a lot of enterprises that don't have a large budget, or there are a lot of enterprises that support and want to support open source. But the review, the ability to do and affect code, the ability to have a bug bounty around some of the code has not always been an option. So I think this is a great step in the right direction. I would be curious to see how this is sustainable over the long term, where the funding is going to come from for each of these open source projects to continually pour into these bug bounties and continually incentivize researchers to look at these open source projects, because there's a lot of open source that is utilized in enterprise all over the place. We think about all of the software we deploy on a regular base system just to get an end user to a point where they're comfortable using that for their daily operations. There's a lot of software there that is open source. So I think this is a good step in the right direction. I think it's going to be a long road ahead, and the funding is going to be something that's going to have to be considered very carefully. But I believe that there's good intention here that, if you are an enterprise that is large, that utilizes this or even supports some of these foundations or open source projects, this is a good place to invest money. This will allow those bugs to be discovered not by, say, an adversarial group or even a researcher that may not have the best responsible disclosure understandings, and have this done through the bug bounty properly. This kind of starts to mature those open source projects to a much more sustainable enterprise model that will fit inside of enterprises as we move forward.
Yeah, and maybe, as you're making those comments earlier too about sudo and some of the research that Qualys was looking into, they also found 24 vulnerabilities in XM over, I think, last summer. So there's also, there are the Apache servers, there's the Linux kernel, there's the very common open source projects that everybody knows about. OpenSSL would be another great one, but there's a lot of these other long tail, if you will, of open source projects that perhaps aren't as exciting for someone to dive into, or there's just no budget there for a bug bounty reward. So maybe from that perspective too, if this can encourage some more attention to those the unlooked at attack surface, but that could still have some vulns lurking around after 8 or 10 years, just waiting for somebody to find. I suppose that actually would be a really great outcome of this type of financing of just more bug bounties and more open source.
Definitely, I think this only can end well for the open source projects. Again, it's going to take some maturity and some support by enterprises to kind of help facilitate some of this from a funding standpoint. But if we can do that, like you said, there's a lot of places that could get looked at that probably doesn't, because it's just not interesting and there's no incentive for a lot of the people that might look at something from a security standpoint.
Yeah, and I think that's a good setup for a final article here. I want to just call attention to the last bit. It's a State of DevOps report from the Google Cloud research, who've been looking at for at least past 3 years, at least, possibly more. Basically, what do DevOps practices look like, and what does it mean? What does the maturity level of DevOps practices look like, and for basically delivering software effectively? And a part of it explicitly called out is security. And just to call on to, I'm looking at pages 24, 25 of this report. It's a long report, but I do encourage reading it for the DevOps side of things as well as the security. But they're saying that high quality quality documentation, teams that had that were almost 4 times as likely to integrate security throughout their development process. And I think that does speak to the idea of very much the last segment where we're talking with Anita and Patrick, but just the idea that if you're focusing on that communication aspect, meaning documentation about what does our app do, what does the code look like, how is the code documented, that probably is a level of maturity that also means you're bringing in testing, whether it is some fuzzing, which would be fantastic, or just some basic AST tools, or you just do have a bug bounty program that you are that you're sponsoring. But I think for me, the other part of it, though, that seems tough to still scale, tough for organizations to address where they need more budget, more people, is that so many of the security practices they call attention to that elite teams do, basically teams that are doing really well in DevOps, it's security reviews and more security reviews and building code that has been security reviews and having AppSec or InfoSec be part of the conversation early on to do security reviews, design reviews. So it's definitely a lot of communication, a lot of collaboration and talking, but wow, that's a lot of AppSec people that are going to be busy doing reviews of code out there. So hopefully there's something in automation that's going to also complement this type of these type of effort.
I don't think there's any way to do this without the automation and even I hate to say it, the AI and ML side of this. Without some of that, these smaller teams and the speed at which AppSec and applications and development is moving just to stay with something that gets pushed out to production is incredibly fast, and the teams aren't getting any bigger, the workloads aren't getting any smaller, so that really does leave a programmatic fix, which is going to have to be some of the automation piece of this and the orchestration. So you're right, the communication side of this, where we see good teams working together, is where we see good security. That's almost a direct correlation every time. And the integration between the teams and the ability to communicate is good, but that still is only a small piece of the puzzle. And like we talked in the last episode, there's multiple pieces of this and angles that have to be addressed in order for that to be successful at any size. And I think there is a big disparate difference between the elite and the well-funded, well-budgeted, well-staffed teams and the DevOps teams that are scrapping and startup and pushing stuff out very quickly. So I'm excited to see some of the automation start to come to fruition and really start to make a difference, especially in the AppSec side of this.
Especially in the AppSec side of this. And as a final note, too, I did want to say, happy birthday, happy anniversary to OWASP, who turned its 20th year of them. And their projects and multiple projects, I should say. And I guess one of the things I'd love to see more coming out of that is kind of what you were alluding to just at the end there, Tyler, more automation, more projects. So we have, of course, the venerable top 10 that it's a little bit easy to tease and make fun of, but still that just falls in that awareness category. Let's see, the next 20 years of OWASP developing a lot more linters or basically frameworks to help us make the SSRF go away, so it doesn't yet land on the OWASP, the next version of the OWASP top 10 list. So I threw in a link to the conference that they had for their 20th anniversary celebration event. I don't think they did some live streaming. I don't think those videos are yet up on YouTube or yet recorded to watch after the fact. But we'll keep an eye out for them and let all of our listeners know. So with that, Tyler, I want to say thank you for joining us and see if there's any final messages you'd like to send out for our poor AppSec and DevOps teams, or they're those large scrappy startups or there's large enterprises with bigger budgets.
Hats off to you guys, because your job's hard, and we will keep working on the offensive piece to help push you further.
Well, hats off to you, Tyler. Thank you for joining. Thanks everyone who was saying hi and chatting with us in Discord, and thanks to all of our listeners after the fact as well. We're going to not take a break. We're going to take just a week break. I lost doing it live. Forgot to scroll down. We're just going to say thank you for joining us. We'll see you next week on Application Security Weekly.